So we are going to move kind of quick because we have two sections, but I don't think it's going to be too bad. I think we've all seen these before, and we're going to kind of be okay. And if there's any big questions that pop up as we go, just stop and say, hey, wait, I didn't get that. Because, yeah, we're going to kind of fly through linear. Because this is like the only day we're going to do linear functions. Because we've seen them in college algebra. So we're just going to blow by them and then get started with the real stuff. Awesome. So linear functions are just functions that are straight, super straight, not even like, they're like exactly perfectly lines, right? Not just kind of lines, they are lines. Every dot that you connect would be in sequence with the other dots, which means it has the same slope all the way through. So before we use this word called average rate of change, big old word, which just meant even if it's not linear, kind of, how much is it changing? But now we're saying, well, you know what the average rate of change is for every single two dots on the whole line? The exact same. No matter what two dots you pick, the average rate of change for every dot is going to be exactly the same. So now it's not even called average rate of change for this type of function. It's just called rate of change or slope. There's a couple formats for the lines, but we're going to get to them as we go through because we're not starting actually with the full line. We're going to start with something even a little simpler than that. So we've got equations, functions, tables like we've seen before, and graphs like we've seen before. We're going to come back and fill in the gaps of which each thing is, but first we're going to start with just what is slope. Just the core foundation, fundamental thing of linear functions, which is what's the slope. If you know the slope, you can pretty much acquire everything else. So I know that we just skipped through a whole bunch of information on the front. Go home, read it, read the book like everybody does. Everybody goes home and reads the book after class because they are studious and love reading and want to learn more. Because the book is, if we just sat here and read the book, it'd be longer than an hour. So we don't have time to do that. So you have to do that at home. Nevertheless, find the slope. We've already done this. We just didn't call it slope. We called it average rate of change. But then we drew a little arrow and said it's kind of like the slope, kind of like the y2, y1, kind of like the delta y over delta x. We've got that same exact thing here. We just took out the word average rate of change. So let's label these four things. Any thoughts on any one of the four? Which one, though? No, okay. Which one? There you go. Thank you. X1. 3 is Y1. I'm going to make those two. I don't know why I did that. And then I'm going to change colors for these two. X2. And can you hit me up with a formula that combines all four of those things? Okay, hang on. I have an idea. If you're a girl, I want you to do exactly what we're doing right here. Go. Right now. Go. If you're a guy, switch the ones and the twos. I know that's weird and scary or whatever, but if you're a guy, do what's in green. Whoa, that's not good. Yes.
So why isn't the other point x1 if 0
That's what the girl guy thinks for. We're about to find out. Yes, that's a great question. That's exactly what this girl guy thinks for. If you're a girl, do the top thing, the normal thing we started with because y'all were the ones who said it. Guys, you should have said something earlier. If you're a guy, do the green stuff. Go. Go, 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 go. Guys, green, girls, red and blue. Let's see what happens. And I will do the green. So 3 minus 4 over 2 minus 0, which is well, I'll be quiet. So the guys would have got me something. Any girls done? What'd you get? Wait, what? Oh, we need to be careful. Okay, hang on. Let's be careful. Are you sure? Negative. Oh, now I got to go and do the girls section? Hang on. I trust some of you. Let's find out. So 4 minus 3?
Minus 2.
What?
4 minus 2.
We're doing y2. Look at the formula up here.
Oh, okay.
Y2 minus y1 divided by 0 minus 2. And that's going to end up with negative 1. Oh, whoops. Sorry. You're right. No, you are right. Mind your way. I can move back a little. Negative 1 over 2. That was kind of scary. Are we all okay with that so far? Be careful. Be careful with those negative signs. And be careful plugging and chugging it into the right spot. If you want to be even more careful, use parentheses. If you want to be even more careful, I've got colored pencils. Come and grab colored pencils and do all 4 numbers in a different color so you see where they get plugged in. But yeah, just be really careful when you get them plugged in. So it just asks us for slope. And then tell us whether it's increasing or decreasing. Any thoughts on that based on the 2 slopes we've got? So m equals negative 1/2, and you're saying decreasing because of the negative sign. Bless you. And we skipped over it. We went really fast, but you've read the book and you've been in Algebra 1 before in 9th grade. Decreasing looks like this, right? That line right there is the decreasing line. We also talked about it when we did behaviors of graphs. Remember we talked about up on a roller coaster, down on a slide, that kind of thing. So we kind of have an idea of what decreasing looks like. All right, let's keep rolling. I think this is the exact same question, just with words, which is more annoying. So any ideas for the x1? And we don't have to split up guys and girls. We can do it all together this time. x1, y1, x2, y2, we got to kind of figure them out. So we got a population and a year. Yep, year. Oh, we've actually said something about this, and I'll say it again. If you ever have time, what is it? Time is always, I'm going to say always. Caveat, pretty much always. Time is always x, just is. Think about a watch. Time x, boom. Time's always x. Yeah, so I guess we just get started labeling. So 2009 is your, and 2012 is your, and which one of these comes first? That one comes first. So y1, y2. So we've got ourselves 1868 minus 1442 divided by 2012 minus 2009. That is something that I want you to do. I'm bad at math. What's up? What'd you get? Well, give me the thing over the thing, and then we'll do that. Can I get an amen on that? You're still writing. Is that real? Is that a real amen? Oh, okay, perfect. And that equals? Thank you. 140? No, I disagree. I don't think the answer is 142. No, I disagree.
Okay.
Oh, I just don't think that's the answer.
Okay then.
Because it's not per year.
Well, that's half of the answer. No, I'm just missing one word now.
Population.
Yeah, or I'll use the word people, but yeah, if you wanted to say population growth, you could. Population growth per year would be fine. I'm just going to say people per year. That's the answer, right? Usually we don't have those, just sometimes word problems we do. So there you go. Sorry, being a butt about it. Slope, that's slope. Wrap it up in a nice box. Careful with your negative signs. That's the only thing that's really scary. Sometimes you get the double negative, right? The like y2 minus, and then y1's negative, so it turns into a plus sign. Be careful with those. Now we move on. I told you we were getting back to all that stuff up top. So here's that stuff up top showing back up again, which is the first, and I think even though it's not the most common, I think it's the most important equation of a line, even though it's not the most common. Yeah, why is it? Any thoughts? I know this is kind of out of left field and we haven't even done a problem with it yet, but any thoughts as to why I would say this is the most important version? Oh, that's a cool thought, which is not what I was thinking, but it's super cool thought. What could you like manipulate this to be? If you just wanted like playing around with an equation, if you divide that right there, right? Divide out that big ugly. Don't do this, but if you were to divide out that big ugly thing, you know what you're left with on this side? And you know what you're left with on this side? Y minus y over x minus x, kind of. I know there's a 1 there. I know, but where did they get it from? That's it. And now what did they actually do with this formula is they just removed one of the points. So they took away the 2 that should be right there, right? And you know what they're going to do with that, taking away that 2? They're just going to leave them as, they're going to, instead of plugging in a point to x1 or x2, y2, they're going to leave it as x and y, which are called what? Variables. They're going to leave them as variables because now if you have 2 variables, you have a equation. And if those 2 variables happen to not repeat on the x, you have a, hey, thank you. And if you happen to have them not repeat on the y either, you have a even more, less specific, 1-to-1, sometimes linear. If you have them not repeat on the x or the y and consistently change on the x and the y, because they could be consistently changing with increase, but consistently changing x per y, we've got a linear. So there's a progression of kind of like how you go from a quadrilateral to a rectangle to a square to a, and you're like adding one little thing to define it. Okay, so we've got slope, and they turned the equation for slope into an equation for a line by getting rid of one of the points. So here we go. They've given us the same thing that they've been giving us, but just written a little bit differently, right? So any thoughts as to x1 here? They're just written it a little differently. If you want to write it the same way, we can. How else can you write this red underline thing? Thank you. 2 comma negative 11. And then this blue thing? That might be a good idea. Just, I know. So 2 would be x1. 11 would be, 4 would be, negative 25 would be, and I think we should just plug and chug, yeah? So what does m equal? M should equal negative 25 minus negative 11. There's that warning I was saying that's going to pop up. You got 2 negatives, it turns into a, and if you want to be way more careful than I've been being, throw some parentheses around everything. It's not bad to do. 4, even if it's just like those 2, you can still put parentheses around those bottom 2, just to be safe. All right, well, I'm bad at math. I don't know the top thing. And so that's total of negative 7 as your slope. But unfortunately, this didn't ask us for slope. It asked us for a function. What the heck is going on right there? It asked us for a function, right? So I probably should have not done that right in the middle. Move it over a little bit. So we just have this new equation, right? I'm not zooming back out. What's that new equation? Don't look. Close your eyes. What's the new equation? You have to know it. Someone was asking earlier, maybe it was the other class, about if there's equations on tests and how the difference quotient was given to us. I promise you this one's not. This is a brain one. Oh, we have all those things. Wait, but we don't have y or x. No, we don't. We don't have y or x, not y1 or x1. We don't have y or x. Those are the variables. You leave them alone. Don't. I've seen too many times on tests people plug both points in and then just write a true statement, but it's just like a random 2 equals 2 statement. It's like, yeah, 2 does equal 2, but it's not helpful. So we're going to leave them alone. Yes. Don't be tempted to plug in both points. Just plug in the first one. So y minus, I forgot what y1 was. That's going to change later. I'm going to leave it alone for now. Equals -7 times 2. Boom. Cool. And let's just do a little simplification. I'm running out of room, so I'm going up here. Y plus 11 equals -7x plus 14. What? Come to office hours? No, I'm not kidding. So -7x plus 3. Y'all go with that? Good? Unless I messed up, which just happens. Okay, I want to point out the 2 forms that just happened, and then we'll move. This form has a name. I'll abbreviate it most times, but it's called point slope form. And I'll change the color real quick. This form has a name, and it's the one they asked for in the problem statement. What was the name of that one? Slope intercept form, and I'll usually just write that underneath. Why? Why might it be called slope intercept form? You know this. What's the y-intercept? No, that's a number. Hey, the y-intercept is 0, 3. I know it's being mean, but the y-intercept occurs at the y value of 3. The y-intercept is 0, 3. All right, how are we doing with this time? Ooh, that's tough. That's tough. Word problem with the linear function, where they've given you here's what we'll do. I'll get it from you, I'll label it, and then we're gonna go to the try at 5 because I trust you. So, and if you want to work on it during lab, we can come back and work on it, but let's label it. What do we think? X1. Pick any number for X1. That's a great idea. Makes our subtraction way better. X1. X2. Sure. Y1. Y2. Sweet. I trust you. You don't have to do it right now so that we can get through 2 sections in one day. But what it asks us to write a linear function, right? And it doesn't even ask us for a form. So either take your pick, pick your favorite. Chances are point slope's the first one that pops up. Actually, no, I don't know. Actually, this one, it gives you the y-intercept, so you can go with either. But let's keep rolling. I think we just finished section 1. I do believe we just finished. Oh, so we finished in half the time. That's great. That was section 1, which was linear functions. So if we were to recap in 2 minutes before it's halfway, in 2 minutes, and you had to recap linear functions, it's probably like 3 things to remember for sure. But what's a recap of linear functions that we just did? Point slope, and then memorize it. But if you can just remember point slope, you know you got something. So point slope form, and you got to memorize it. Slope intercept form, and you got to memorize it. And then I think before those 2 things, you have to know one thing. The formula for slope, using the points. So you've got 2 forms, but before you can do that, you usually got to find that slope somehow. Yeah. Sweet. Did anybody just do that real fast while I was talking? What is it? One half x plus. That makes sense to me. Because you went over 2 and up 1. Yep. Here's what we're about to do with graphing. This is the x, right? So we went over how many? 2? And we went up how many every time? Wait. Oh, no, look at this. That's not over 2. They went over 2 and up 1 right here, right? And they went over 2 and up 1 right here. Pretty consistent, right? But here they went over 4 and up how many? Is that still consistent? Yeah. It's just a little scarier. But you'd end up with the same slope. No matter what 2 points you would have picked, we would end up in the exact same spot. What's up? This is awful. Fractions and whatnot. All right, well, suppose we can do it. Now we move to graphing. That was equations of slopes, formulas for slopes. Now we graph slopes, graph lines. So graph this by plotting points. I'll tell you, most of the time we pick the same 5 points. I might be picking a different 5 for this one to make my life a lot easier. But I know all the time I'm going to plot the same point in the middle of this table. You know which point you start with? 0. All right, thank you. Well, 0 is not a point, but the x value of 0 turns into a y value of 6. And it's not technically true, but sometimes on tables I'll do that to remind my brain, or maybe do it outside of the table even, to remind your brain, oh, that's just a point. It's not a different concept than we've been learning. It's just an xy point. So then I'm going to go over to the graph and plot 0, 6. Any thoughts on another x value to pick that's actually pretty and nice? Yeah. Usually I do 1. I heard a bunch of people say 1. Usually I do 1. That fraction looks awful. 4 looks great. And then negative 4. 4 looks like it's going to be real nice because you know what it's going to do to that bottom? Cancel it out. So what is f of 4 then? I might have to go off to the side to do it. F of 4 equals negative 3 over 4 times 4. Oh, that is lovely. Cross, cross. And we end up with positive 3? Four comma 3. I'm going to let you in on a little secret. You know what? If we're working with linear functions, and you know it's linear because of the y equals mx plus b formula, guess what? We're done. Grab your ID, grab your phone if it's super straight on the edge, grab something and draw the line. Or count and draw the line, like you know. You can go down 1, 2, 3, over 1, 2, 3, 4, but we're kind of done. Though, because the problem asked us to, let's do one more point just to be safe. Let's go on the other side of it and go negative 4. Say, what do we get if we throw negative 4 in the mix? Negative 4, 9. Negative 4 comma 9. Does that track with that whole ID thing I was saying? Here's how I'll know. I've got a straight line tool, which is your ID. I'm going to connect these 3 dots and then extend it and see what happens. See if it feels like it's going the same. Oh, look at that. Perfect. If you want to fill in the next spots, maybe you go 8, comma, and negative 8, comma, 12. Or no? Yeah? When they say the word plotting points, your brain can think plug and chug, not G. Plug and chug. Plug the X, plug the input in, get an output. Plug the X in, get a Y. Example 12, completely different. You could do the same thing. You're taking a test, do the first thing. Or the second thing, do which one makes more sense. This is a chance to do it without ever plotting more than 1 point. It's saying, hey, we gave you the y-intercept because somebody yelled it out earlier. Any thoughts on what the y-intercept is here? No. Nice. It is 5. I'm sorry. But it's actually 0, 5. So let's go plot that thing. 0, 5. And then what is the slope? Which means ... in layman's terms, or in my brain's terms, I draw down 2, right 3. And I always keep that negative on the top. I don't know why. It just makes my life better. I always keep that negative at top. Even if it's on the bottom, I just go up top, please. So I'm going to go down 2, and I like to do these little bubble things. Over 3. Put a dot. Do it again. Down 2. Bless you. Over 3. Put a dot. Down 2. Over 3. Put a dot. Does that look like it's a line, a constant slope, a constant average rate of change? To me, it does. Look at that. Sometimes it doesn't give me that arrow on the end. Boop. You want to be super cool? Plot every single point. If you want to be like, no, I'm just saying like on the graph, like do all 12 that fit there. I don't know. If you want to be really cool and make sure you get 100 on the test and you don't miss anything, plot them all. Find a point on the graph above that has a negative x value. Oh, I didn't plot any. That question was like tailored at me. Like, hey, you took the easy way out. Any thoughts on how to find a negative one? Follow the exact same pattern, but go backwards. Which would be, here's what that would be in, like, is that allowed? Is that legal? If you think about the slope, is 2 over negative 3 not the exact same thing? Just in math world terms?
Yes.
And that would be up 2, left 3. Super allowed. Now here's the problem, or not problem, but is negative 2 over negative 3 the same thing? No. So you can't do both. You can't flip and flop both. You got to, if you're going to go backwards, you got to actually move the negative sign and not just double apply it. We're going. So let me, underneath try at 6, just to like really clear this up. Your slope is negative 2 over 3, right? That doesn't tell you anything. So in the first graphing, we went negative 2 over 3, which to us meant down 2, right 3. But then we said, well, that's the exact same thing in the math world as that. And that means up 2, left 3. And you're allowed to do either. Or both. You're allowed to do both. Cool? It just does not mean both negatives. Can't mean that. So let's go over 3, 1, 2, 3, up 2, 1, 2. And I guess 1 point's fine. Negative 3, 7. Not too crazy? So we can graph it. Yay. All right. Need we do all 4 colors? I don't think so. But we can start with orange. I think it's just saying fine. It's like, hey, here's 4 lines, 4 chances to practice. What do we know about orange? Okay, so for orange, we've got a y-intercept. Good call. Might as well label it. Y-intercept of what? Zero, 3? Bless you. Do we know anything else? You might have to look at your paper. Is your paper done well? Yeah, better than up there. Can we? Where's the other? Oh, I see it. Yeah. Negative 1 comma 1. Cool. So then I'm just going to write the word other point. Negative 1 comma 1. And do you think it's easier to go y2 minus y1 over x2 minus x1? Or do you think it's easier to zoom in real big and go 1, 2, 1? That's easier. Up 2 means rise 2. Ooh, we didn't even talk about rise over run. That's on me. And then a run of 1. So that means your slope is what? So it means for the yellow, your m equals delta y over delta x. Fun other way to look at it. Change in y over change in x, which is a positive 2 and a positive 1. And now, instead of even doing point slope formula, I'm going to jump straight to the, instead of doing point slope form, I'm going to jump to the easy one because they already gave us our y-intercept. So y equals 2x plus 3 because we've got our slope and we've got our y-intercept. Now, it's not always so nice that your y-intercept's given. Sometimes it's not. And then you have to do a little more work. And that would have been line number 1. Let's skip to line 4 because it's the only one with a different slope. So skip to the dark blue line, or line 4. Are your papers in color? Nice. Good job, me. Any thoughts about the dark blue line or line number 4 that we know? Yeah, even if we don't call it out yet, which you probably could have real quick, but I think it's cool just to note. It's a negative slope. It's the only one of the 3 that has a negative slope. If you were to start walking or reading a book, it's the only one where you're sliding instead of climbing. We know the y-intercept again, and it's actually exactly the same. What? I think it's positive 3. Oh, we're doing dark blue, sorry.
Oh, okay.
0, negative 3 is the light blue. Oh, there's 3 color blues. That's terrible. I now see that.
Good job on your.
I didn't make it. Teal, light blue, dark blue. Feels like what it is. What do you want, turquoise? Aquamarine? Slope, anybody got a good slope? I'm not even going to go up to there. I'm going to go way down here to find it, right? Just for fun. Down 2. Negative 2 over 1. Change in y of 2. Change in x of 1. Which means the slope is negative 2 over 1. Which means we have y equals negative 2x plus 3. Okay, graph lines. I know we've graphed lines before. So. Don't lie. We should get a Nerf gun. I should get a Nerf gun. What?
You get half credit if you did it in reverse.
Sure. What do you mean?
Like instead of negative 2, you do 2 over negative 1. This is just
No, you get full credit. That's the same exact thing.
I just wanted to know if anyone else did it.
Yeah, if you were to mess up, or not, it's not even called messing up. No. If you were just to count differently and you went like this, mathematically speaking, that's the exact same thing.
Okay, I just wanted to know if
You're good.
anyone else took the credit for that.
Yeah. I mean, do that, but you're fine. I know you start taking a test and your brain starts closing up and you're like, what? I knew all this stuff and then nope, it's gone. Ooh, x-intercepts are really fun because they're actually pretty darn easy. When we've already defined them, someone was informing me we've already said them a bunch of times. What's another word for x-intercept? X-intercept can also be called a zero, solution, one more, root, also known as rocks, if you want to try to remember that acronym. It's not a good X. So, the reason it's called a zero is because you set it equal to 0. And that's what this says. Set it equal to 0. So, instead of f of x, you know what you got?
0.
Equals all this stuff. And then you just do math. I know that's mean. You just do math. Did they? Oh, really nice, huh? So 4 equals quarter of x, which means that x equals 16. Wait, y disappeared? Because we put so what is y? So if you're plugging it into a point, you're getting 16 comma, and that is an x-intercept. You know what's not an x-intercept? 16 as an answer. Thank you. Though sometimes if you're looking around on worksheets online or whatever, you'll see, like, what's the x-intercept? And then the answer key will say 16. It's like, well, kind of, like half of it. But all right. This is one of the easiest to confuse, but also easiest topics, is if you have these two kinds of slopes. So I guess I really maybe should do this first at some point and just move the example up. Oh, this wasn't even a try it. It's just an example that we grabbed because it's good to see. Easy to confuse, but it's really not hard. The biggest mistake made is which one gets the x and which one gets the y, right? When you're trying to write the equations. So there's an acronym that doesn't mean anything, and it's not a word. I wish there was a better one, but my algebra teacher taught me it when I was like 12 or whatever, and now we're just stuck with it forever. Hoi vux. Hoi like today, vux like not a word. Hoi vux. Is that not today? I thought hoi was today. But is that how you spell it?
Yeah.
Okay, great. So hoi like today. Well, I'm not going to say it. What? Oh, crap. Oh, nice. Yeah. Oh, dude. Memorize that before Wednesday. So the hoi, what do you think the H stands for? If you're looking at that picture. That's exactly what it stands for. What do you think the O stands for? I know it's weird. It's not an O. It's not an O. 0 is the what?
Y.
Mm-mm. Mm. Mm. It's a 0, not an O. I don't know how to draw. I guess you could like. Yeah. And Y gives you Y equals. That's the format. Hoi. Horizontal means 0, slope means Y equals format. So what does Y equal in this case? The only number that the line touches ever? Boom, you're done. For the sake of time, can't do it, but I really like doing this exploring thing where it's like pick any 3 points on this whole thing. What are the 3 points? What is the common thing between those 3 points? The Y value is 4, right? If you just look at the points, if you write them out, you're like, oh, look, Y's are 4, so Y better equal 4. One way to look at it. There was another way I've forgotten now, but. Oh, write it as Y equals mx plus b. The m is 0, and it takes away your whole m, so now it's just Y equals b, pretty much, which is true, Y equals b. Okay. Slide over here. So that pretty much informs this. What does the V stand for? That's what type of line it is. What does the U stand for? U. That's the 0. The 0 stands for 0. What is it? It's a U. Undefined slope. No slope, even, if you want to be cool. And the X probably stands for? And in this case, X equals what? I almost said 6.5, and then I re-looked at it. I literally was like, 6.5? And I was like, wait, no. Looks like 7. Maybe it's 7.1. You don't know. What? No, that's fine. I think we know what they're asking for. Hoivux. Everybody say Hoivux. That was not everybody. Everybody say Hoivux. All right, when you're taking the test and you forget, try to remember that. You think I'm being stupid or silly or whatever, but I grade these tests every year. And every year, just out of the speed of taking the test, you just write y equals instead of x equals, and there goes 3 points or whatever. It's like, I knew that. I just was going too quickly and messed up. So when you get to this part and there's one of these, just Hoivux. Try to think about hoi. And then you don't have to remember the word. Just hoi, horizontal, 0, y, cool. All right, last but not least. Okay, we're going to make it. Whew. We made it through 2 sections in one day. That's amazing. And one whole chapter, because this is all the linear functions we're doing. Perpendicular lines. What? Did I skip something? Yep. Great. Parallel lines and perpendicular at the same time. These are a pretty much analysis of slope. And then nothing changes. Nothing changes with the whole problem except for the analysis of slope. It is look at the slope, analyze it, and then rewind to the beginning of the day and use the steps we've already used. So parallel means they have the, you've seen this before, everybody has. I don't see the words on here. I mean, I guess there's the word same, but same, yeah, let's write it big. Same. Slope. Ever seen that symbol before? Like that? Same slope. And that's all you need to know. Then you rewind to the beginning of the day and solve the problem. That's it. I don't want you to think it's a whole new type of problem with new ways to solve. It's the exact same problem. You just look at the slope, resolve the problem with the same slope. Perpendicular means something kind of different. There's a big word for it and a small word for it, and we'll write down both. But anybody know that big, nice word for what's happening? That's half of the big word. That's the second half, reciprocal, because it does get flipped as a fraction, which is what? Reciprocal. Is that how you spell that? Negative reciprocal. Or actually, negative is kind of tough because what if it's already negative? Well, I guess negative, then it flips and it becomes positive. You can write negative. I'm okay with you writing negative. Sometimes the word that I've heard used is opposite. Negative, I'll put parentheses, opposite reciprocal. Either way. I don't ever do that. I just try to think of it. If you had me last year, remember what I said it was? No? Okay. I'm a bad teacher. None of you are going to remember this next year. I just call it a flip. Well, what are you doing? You're flipping the sign and you're flipping the fraction. You flip the sign, you flip the fraction, you're done. So it is a negative reciprocal. Remember that. We know that. Just when I'm going through these, I'm like flip sign, flip fraction, done. Okay. And that thing looks like this. So negative reciprocal, oh, I should have written slope. Sorry. Negative reciprocal slope. Flip the sign, flip the fraction. You got your slope. Go back to the beginning of the day and solve. All right, so given this function, pretty easy function actually, thank you. Given this function, what's the slope? So what's the slope of a parallel line? So what's the slope of a perpendicular line? Flip the sign, flip the fraction, negative 1/2. And then it says, write an equation for this line passing through 0, 0. That's a softball. So how do we apply 0, 0 to those two slopes? One at a time, probably. I'm doing point slope because we need to see it again. even though we could just, that is the y-intercept, so we could go straight to it. I'm going to do point slope so we see it again. So y minus 0. Oh, you're right. Good call. Hang on. We have the point 0, 0, right? Might as well label it x1, y1 equals 2, x minus 0, which means y equals 2x. And so I think we're going to have a pretty parallel argument for the next one, which would be y equals negative 1/2 x. I know you can do that with no, if your brain recognized that's the y-intercept of 0, 0, I could just plug it into slope-intercept form. Yeah, we just only saw point slope like one time, so fun to see it again. All right. Hey, almost perfect timing. Just a little behind. If I wouldn't have done that second slope form, the dark blue one, we would have made it. I knew that when I was doing it. But this is a good problem. This is a wrap it all up into one problem. This is the whole day wrapped into one problem. Literally starting at the beginning and working our way through. So, starting at the very beginning, don't look at this problem, don't look down. What was the first thing we did? We found the slope. Guess what the first thing we have to do here is? Using those 2 points, find the slope. Let's label them. All right, I'm going to talk slower. This is it. If you don't watch anything and you need to go home and relearn today, this problem is everything we've done. Negative 2, 15, 2, negative 3. Let's label them. Give me some labels. You're saying x1. Oh, I messed up. y1 and 3, negative 3 is. Okay. Pause. What if you would have messed up and done it the other way? Exact same answer. Cool. Just in case you're watching at home and you're like, well, how do I know which one you just picked? Doesn't matter, right? All right, let's move forward. Formula for slope. No, formula for slope. All right, and then I'm going to parenthesis this up just for fun. Negative 3 minus 15, 2, and I super parenthesed it just to be cool and safe. Negative 18 over 4, which if we reduce that a little bit would be negative 9 is our labeled just for niceness. Okay? Now, we actually do have to, we're going to come back and do what we did in the middle. So that was what we did at the beginning of the day. We're going to skip and do the end and then retroactively do the middle. So we got ourselves a slope. One of these words is bold and telling us what to do with that slope. So now we take that slope and we go flip, flip. So it's no longer negative, it's now positive, and it's no longer 9 over 2, it's now. So I'm going to write this perpendicular slope just so we know what we did there. And our perpendicular slope is 2 over 9. Look at that little thing. I just thought to do that. I should always do that. See how I did the M with the little perpendicular sign? I don't know. It's kind of fun. Okay? We've got a slope. And what point is it passing through? Passes through 6, 4. So we've got ourselves a point and we've got ourselves a slope. Dot, dot, dot. Amen. I am out of room, so I'm going to do something that you can't do. Isn't that nice? All right. What is that point slope form again? So y minus 4 x minus 6. Did it tell? Yo. Did I? It didn't. That's what I was about to ask. I was gonna say, did it tell us which one? Nope. If it didn't tell you which one, leave it alone. This is called point slope form. But because it's not 10 yet, I'm going to go ahead and be cool. So it means we got y minus 4 equals 2 over 9 x minus 12 over 9. Just distributed. 12 over 9 reduces to 4 over 3 divided by 3 both times. Yep. This is what nobody likes this. Nobody likes what's about to happen. Come to office hours. Please come to office hours. Plus 4 plus 4. So y equals 2 over 9x. 4 kind of turns into 12, right? 12 minus 4 is 8 plus 8 over 3. 4 is the same thing as 12 over 3 is what Devin did really fast in his brain. Good job. Or on your paper. All right, 4 minutes over, but that's not too bad to do 2 sections in a day. One section we would have been done so fast and been like bored. So, and I trust your ability to learn. All right, questions? It's okay to have a question. If you don't want to ask it now, come up and ask it during the break. We'll start a new lab. I'm pretty excited about this lab. It's pretty fun, I hope. We'll see. All right. Take a little 5-minute break and then come